Welcome everyone to the February 26th, 2018 Kubernetes SIG Apps meeting. So I'll start this off by sharing in the chat here the document where we have our agenda and we capture our meeting minutes and all of that stuff. So today we've got a lot going on today, and we may not even get to it all if we have some good discussion. So the first thing we have up, because I don't think we have any announcements. I don't have any right now. Does anyone have anything to share? We had the Helm Summit, but that will be in a little bit. We'll talk about some of the stuff coming out of it.
Maybe it's worth reminding that there's a code freeze happening at 6 p.m. Pacific time, if I remember correctly.
Is that today?
Generally later today. Yes, today.
All right, thank you. So code freeze coming. For anybody who didn't know, 6 p.m. Pacific time today. Thank you. And so I guess with that, we'll hand it over to Phil for the demo. Are you ready?
Yeah, I'm ready. Hey, everyone.
All right. Hello, the floor is yours.
All right, thanks. All right, so I'm going to go ahead and share my screen here. All right, is everyone able to see that?
I can.
Yes.
Great. Okay, so what I'm chatting about today is something that I demoed briefly, I think 2 weeks ago, but a little more in depth. It's about building a toolkit for building Kubernetes API extensions. So briefly, I just wanted to go over quickly what it looks like to build a Kubernetes API extension end-to-end. And so there's actually several steps to this. So the first is setting up your development environment, which may mean downloading and installing a bunch of code generators at a specific version. Then setting up a project workspace, which may mean getting vendor libraries from a bunch of different Kubernetes repos. This can be tricky depending on how you do the vendoring and how many when you pull in your dependencies, you can actually get dependencies at the wrong versions that are incompatible and then spend quite a bit of time trying to unwind that ball of yarn. So that can be something that's hard. In addition to that, you may want to set up the canonical package structure. Kubernetes and a lot of projects have a structure that's very specific where different pieces go. And so mirroring that will make it so other people can understand your project. You may want to set up build files like a workspace for Bazel or a Docker file or a Makefile or all these things. So once you've done that and set up your project, you got to go ahead and define an API schema, which means creating typically, this can be done different ways, but within the core Kubernetes project, it's done through creating a types.go file. Anything in that types.go file, the Go struct with specific annotations, possibly creating integration tests for the storage of that schema, and making sure that all the fields are correctly set the right JSON stuff so they don't just get dropped silently. Then adding validation onto that, and then finally running code generators that you downloaded with the specific right set of flags against your new types to generate clients and informers and listers and all this sort of stuff that you're going to use for your controller. After that, you need to set up your controller business logic, which means setting up a worker queue with setting up listeners for informers, defining a reconciliation function, wiring all these pieces together so that you have a single set of informers shared across many, possibly multiple reconcile loops. And then only at this point do you really get to write the business logic for your app. Until this, you haven't really done a whole lot. And then finally, once you write that controller business logic, you need to package up and publish this thing, right? Which means building container images from your project, setting up RBAC rules potentially and service count, deciding how you want to install this, like where it should be installed, possibly building reference documentation for this, and possibly certain extensions require additional resources to be set up, like TLS certificates, installing services in these pieces. So there's a bunch of different pieces to this, and each one of them can be a little bit challenging. So I'm going to switch over to terminal share now here. But the philosophy behind this is not that this stuff is impossible to do. A lot of people do it, but it feels a lot like walking down a hallway with a bunch of marbles on it, right? Like, it would be better if just the marbles weren't there, right? Because it's just opportunities to trip and fall and get things wrong. So I'm going to show you the set of commands that does all the things I just said. I'm going to run them all at once and then kind of talk through what they're doing. So the first command here sets up the initialization. That does the project structure I talked about. It sets up a vendor directory. It unpacks a tar, so everyone's on the same set of libraries, so you don't get people with slightly different versions of transitive dependencies that then have different bugs in them and different behaviors. So we all get to work from the same base. And then it sets up the base directory structure. The second command here creates your first resource. And this sets up the stuff I was talking about where it creates the schema file with the right annotations, or the types.go file with the right annotations. It sets up the test for that. It sets up the controller function. It sets up the test for the controller function. It wires all the pieces together. And then now you have a nice place to drop stuff. And you can see here the output from running that command. It gives you a nice little text that says here, edit your API schema here. That's where the schema is, and that's where the test is. Edit your controller function here. That's where the business logic is, and that's where the test is. And I've created the sample for you, so you can just kube control create -f that. So I'm going to, in a different window that you can't see, I'm going to go ahead and do kube control create -f on that file. And then you can see at the bottom it says, like, it just printed insert your code here to reconcile whatever. So you can see it's actually running. And so the last commands I ran were just bazel run to generate bazel rules, and then a bazel run to run the controller. And so you can see we have actually CRDs installed into a mini kube cluster with the whole thing running. So you already have right now, just starting from scratch, you know that you can get an API working. Right, and from here you can edit it and refine it, but you're never in that stage where you're like, oh my gosh, like, I can't get the vendors working and I have this problem that isn't related to the framework I'm using at all. It's just this other random problem. So I'm going to open up some of these files. The first I'll open is the schema file. This should be pretty familiar to everyone. But it does set up these comments for you. The gen client, the deep copy stuff. This stuff changes from time to time. And it's really frustrating when you don't get it correct, right? So we just do all that for you. We show you, like, what the JSON file, JSON tag should look like, the spec and the status, and then just say, insert your code here, right? This is how you edit your API. So I'm going to go ahead and actually edit this. I use Nano. I get made fun of it a lot. It's okay. So I do something like this. Call this new field name, string. Yeah, okay. So then I just added a field here. I'm going to do one more thing, which is I'm going to add some validation to this. So I'm going to go ahead and say, so add this line here that says it has a maximum value of 5, right? And the reason I'm adding it here instead of some other file is because now all my code's together, and when you look at the Go struct, you can actually see that it has a maximum right there. Next thing I'm going to do is going to pop open the test. So again, this was all created for me, and it allows me just to start editing something that works instead of trying to get something working from scratch. So what this does is it does a nice test, storage test. And so this now allows me to add to this the ability to check the validation I just added. So I'm not going to do that at this moment, but you can now use this test to check that you're doing things correctly, and you don't have to spend all that time saying, okay, how do I get an API server spun up, right? This test will actually spin up a local control plane for you. It works on a Mac, it works on Linux. And spin up a local control plane, install the CRDs, and make sure everything's working for So that's your schema. So the next piece is your controller. So we generate a controller for you. I know there's actually a couple solutions in this space, but this one's integrated into this framework and does something similar where it creates this reconcile function for you. And it goes ahead and says, okay, anytime there's an update or a creation for one of these types, it's going to call this function. It's going to read the latest copy and call this function. And this makes sure it does all the correct best practices that Kubernetes APIs use, which is like shared informers. So you're not creating a new informer for each type. Make sure that it has a queue where each key is only there once, so you don't reconcile the same thing 10 times in a row, which can be tricky to get right. Like if you're just doing a pure watch and reconciling on each watch, then you won't get exactly what you want. And there's a nice init function down here. So this gets called with these arguments that have all the kubeconfig and Kubernetes clients already set up for you. And so it has a comment here kind of showing how you watch other things, right? And says, okay, uncomment this, and then give it an informer, and then give it a function to convert whatever you're watching to a key of this type, and you're on your way. And again, the idea here is we want to make it easy for folks to do the right thing that we want them to do, right? Which is write tests and move quickly. And so it generates a test for you that checks that this gets reconciled, right? And all it does is empty here, but it creates an instance here. You can see the create, right? Make sure that there's not an error, and then checks that a reconcile happens within 10 seconds. And so here, after that reconcile happens, you can add your code to reread any objects from the system and make sure that everything's working the way you want it to. Again, this is not an EDE test that requires a whole cluster to spin up. It brings up a local control plane. And so you can even run multiple of these on the same machine at the same time, but you are checking the actual observed logic of the APIs. So what I did there is I went ahead and added the validation to it. So I'm just going to go ahead and show that that validation works by rerunning this thing. And one of the reasons I use Bazel is just because it gets kind of incremental builds tend to be a little bit faster. You know what? I think I did one thing wrong. This should actually be mint. All right. So I just deleted it. Now I'm going to recreate it. Share a different. Let's see if I can share this other screen with you. Here's what I'll do. Run this command in a different window real quickly. So instead of running it over here, run it over here. So I'll just show you the sample. So this is what it looks like, and I've set that field A to 100. And again, if you look at it, it says a maximum of 5. So now when we do kubectl create-app, of course that didn't work. I must have done something wrong, but it should, oh, I know what I did. So I have to actually regenerate the code. This is all driven off generated code. So I'll walk you through. I'll regenerate that in another window while I walk you through something else. So one thing I'll walk you through is how this actually gets installed. And I set up a specific installer program. And the installer program, so this is the installer program. And what this does is it'll actually install a namespace, set up RBAC rules, set up, make sure service accounts are set up correctly, and set up, potentially, depending on what you're doing, certificates and all the pieces you need to run your controller in the cluster. And so this means you don't have to figure out, like, what is the secure way of running my service or whatever it is I'm doing. We just give you the secure way and then give you knobs to override these things. So it has this strategy that it creates here as a CRD install strategy. You can actually go ahead and embed this in another struct that you define and then go and tweak different pieces and say, hey, I actually want it installed with a stateful set instead of a deployment or whatever it is you want to do. And then go ahead and install this. All right. One other thing we're showing while we're on the RBAC rules is this can actually allow you to customize how your RBAC rules are defined. So it will automatically generate RBAC rules for the things that it knows that you're creating for your APIs and give you the ability to do whatever you want for those pieces. But what happens when you want to start watching pods? Well, when you want to start watching pods, now you need RBAC rules that allow you to watch and list those, or when you want to write deployments or different things. And when they're loosely coupled to the controller, it's easy for them to get out of sync, right? And so what we've done here is provided annotations that allow you to just annotate your controllers with what the RBAC rules it actually requires are, and then now we just generate them and install them automatically. And so this means, like, in here, when you update your reconciliation logic in that same code review, someone could say, hey, add the RBAC rules right there. And so those will get generated for you. All right. All right, so let's try this again. This will be my last try. Live demos, man. But in theory, the validation should pick that up and prevent that from happening. I need to find out. I might have broke my dev belt. But I will show you actually where that code lives. Just give a quick look at the generated code. So this is generated code for you from all those annotations. And you can see it generates a bunch of different stuff. This is where the RBAC rules get generated. So you'd have to regenerate the code. But you can see here that the get rules function defines all the RBAC rules that will get generated off those comments. And
yeah, I think somebody found your issue. There's a quote misplaced in your JSON
really?
definition. Yeah.
That's awesome. Well, there's still work to be done. Clearly, the linting on the definitions could probably do some work. Okay, I'll fix that in a sec.
I think we get the idea. Okay.
Yeah. Cool. Anyway, so that's the whole piece there. You can see the RBAC rules just got generated here. So there's the deployments and the pods, different RBAC rules that we're going to install. Anyway, that's it. And the goal here is just to make it so that you have to know less about the best practices today for setting up each one of these pieces, and you can just focus on writing some business logic for your APIs and controllers.
It looks great. Thank you. At the Helm Summit, we talked a little bit about building controllers and things like that, and some of the pitfalls in jumping through this. So it's nice to see something that can help you generate code. All right. Does anybody have any questions? Any comments?
This is on GitHub. I have one. Hey Patrick, thanks. This is pretty awesome. I've seen there are a few things out there. There's some like libraries called Operator Kit. I think two that are called Operator Kit literally, and there's another one that popped up more recently. But I don't know how these things compare to one another and to what you just showed. But the kind of thought I had, my main question basically is what are you thinking to do around the rebase problem, assuming there is a rebase problem? Like, the generator has updated. How do we integrate the latest best practice from the generator?
Yeah, so I'll address a couple of those things. I guess I'll start with the rebase problem. So the rebase problem, the goal is to make that a lot easier. The more generated code we have and the less you're writing, like we just regenerate that from scratch, right? So some of the techniques I'm trying to use for that is to provide default instances of almost all the APIs, right? And so that when a new function is added to an interface, for instance, that it doesn't break your code, right? That we just add, that you embed the default instance, and then we give you a reasonable default behavior. So that's, I think the code generation and giving you sane empty defaults is probably the best way to address that. And there's install commands. So if you download the latest instance, it'll like update all your vendor libraries to the latest versions. The second piece for the operator kit, and I saw API server builder there. So I wrote API server builder, and a lot of this code is coming out of that. And API server builder was targeted at aggregated API servers. And folks that were writing CRDs were saying, hey, I really like some of the controller building. Oh, sorry, what was that? Okay, and so this is kind of coming out of that. And if you saw in the installer, it actually can install aggregated API servers as well. So I'm hoping that we end up on a kit that can that is agnostic to, do you want these through aggregated APIs or CRDs, and can just generate like the implementation. Is it on GitHub anywhere? Right now it's a fork of API server builder because I'm still trying to work through figuring out what repo this will end up living in. There's, I think, the Kubernetes incubator and SIG's repos haven't quite totally settled down yet. So I'm trying to get it as quickly as possible in a better home. Operator kits. I've looked at a number of those, and some of them do really interesting things, and there's some things that some of the libraries do that I like more than mine and probably would try and integrate. One thing that a lot of them I don't see a lot of them have is they don't take a holistic solution from end to end. And so like a lot of the operator ones, kits that I looked at don't, for instance, give you any of the code generators or setting up the schemas, right? And so they say, okay, here's a great way of setting up an operator, but if you want to actually create your own API that you're writing an operator for, okay, well, go generate all the informers and all this stuff, which means doing all those pieces I kind of mentioned, which can get it quite gnarly. And then there's the installation piece, right, which is, okay, how do I actually install this? So I'd love to possibly incorporate some of those, like if there's libraries that are operator kits and that turn out to be really popular, maybe it's possible to offer support for them here.
Okay, and one more question. I wonder whether, code generation could be avoided altogether with a high-level library, but then perhaps it's a very hard problem because of Go and types, right? Because if we had a dynamic language, we wouldn't have to generate anything, actually.
Yes, so I'd say there's a couple we can do better, or rather, I can do much better, right? There's absolutely code here that gets generated that doesn't need to be generated, but I just I started out taking the examples and generating them, right? So right, and then going backwards from there, right? The idea is to refine that into libraries. The nice thing about that approach is at least it's canonical instead of trying to write it from scratch and maybe getting some details wrong. But putting into libraries is better. The things that, like the informers piece, we're going to always need code generation for that until API machinery radically rethinks how they're doing things. The one area where it's probably a toss-up is if you look at the reconcile function in my example, takes the actual type. It reads the newest instance of the type and then gives it to you. And so that probably requires some code generation, right? The code there isn't that much, like just having everyone write the code that uses a client to look it up from a key, right? Or in other cases, such as the admission control hooks, machine control webhooks. It gives you a byte array. And so the examples folks use is they take that byte array and then marshal it into an object. And so I think the ideal way probably would be have the libraries almost there and allow people to just use those directly and support folks just using the libraries directly without the code generation, but also providing that extra layer for folks.
Sounds good. Wow. So you've got something working and a roadmap. Well,
yeah.
We got to get. So for anybody who doesn't know, there's a new structure coming from incubator to SIG repos, and I think it's finally in place. If you track down Aaron Krickenberger, he can help you. I think he's the one who's helping get that going now, but I think all the I's are dotted and T's are crossed if somebody wants to set one of those up. So if you want, we can tie off on that too. It should be working now.
So question, do we think this is something we'd want to sponsor into the SIG Apps repo?
To me?
Anybody. General.
You say so.
I absolutely think so.
Exactly does it entail?
So I went to API Machinery, or not API, sorry, I went to SIG Architecture a few weeks back to ask the question of like, where would something like this go? And what they told me was that it would either go in API Machinery if SIG was going to sponsor it, or it should go as a side project and just be like under Google Cloud and Google Cloud Platform or something like that.
Okay. And then only one other comment. So having spent a lot of time modifying and adding to types.go and doing code generation inside of Kubernetes, the thing I like about this is it actually is a somewhat significant improvement on what I do today, right? When I'm modifying stuff inside of Kubernetes core. And my only other thought was that, like, for the operator kits from the ones I've seen, they seem to provide idioms kind of on top of generated code as opposed to handling the generated code in the way Phil said. So it would be interesting and probably beneficial if maybe they use Kubi Builder to do their code generation. And if they want to provide other idioms on top of the generated code, they could add value by doing that. It would be awesome if we could converge and contribute to one thing that generates our code outside instead of having many things, because many things is leading to many bugs as far as I can see.
Yeah, that's a good point. Like you can already break this up a bit, but we could make it more clear how to do that, where you don't have to take the controller, for instance, from this. You can take all the other pieces, and then you could just hook in your own controller kit piece.
All right. Thank you for the demo. It sounds like we've got a path forward. When you find a home for it, please let us know, because there are people here who are obviously interested in poking at this. And I am one of those people. So please let us know and we'll share it here. And if you add stuff, please come back and demo it for us. But we do have some other things to get to in the agenda today. And the next thing up, I believe, is the discussion topics. And the first one we had was the Helm Summit, which happened this last week. And the Helm Summit, there's notes available. Somebody added it to the agenda, so thank you. We took notes in the session. So the basic rundown of how the Helm Summit went was, it was a 2-day event. The first day kicked off with a keynote. Then there were a number of sessions that were 20 to 30 minutes long. It was a single track conference, so everybody was in the same track. That was followed by a series of lightning talks that were about 5 minutes long. And a lot of this touched on how people were using Helm and some of the use cases, and even how people were working around things in Helm. But there was a lot of the pragmatics of Helm today, and people using it at different companies. There was, I think, WP Engine, there was Reddit, and there were some others who talked about what they were doing. The second day, and the first day's keynote was about where Helm started and where it's going. The second day kicked off with a keynote on, again, where things are going and where we're going specifically with Helm 3 from here. There was a series of lightning talks. Many of these were more forward-looking lightning talks. There was a Q&A with the Helm and charts maintainers who were present. And then there was probably half the day was an unconference style, and where we talked about where things are going, Helm 3, whatever people wanted to talk about. And the notes that are available linked here under the Helm Summit section are notes from the different talks. that happened that day in the different lightning talk session, or not lightning talks, young conference talk sessions. There were some takeaways. I'll tell you some of the to-dos we came up with afterwards. And I think I noticed Matt's took a lot of to-dos away to extract user stories from some of those sessions, because one of the things that Helm 3 wants to focus on is user stories. What are those? It can get easy to get into solution engineering, but what is the root thing that needs to be solved for whom? And we want to kind of try to start extracting some of those from the different roundtable sessions that had. We want to kind of document who the users are. And in my mind anyway, and this will go through pull request and review, you start with the app operators, who are the most important, because that's the end user who's got to get things done. Then you've got tool and extension developers as another type of user. Then there's the developers of Helm themselves. And when I look at the priorities, I kind of do put them in that order, but we're going to document this and get it going. There was a lot of talk on CRDs. And so with CRDs, we're going to set up a meeting to discuss them. I will be sending out in a little bit here today a doodle to start collecting times for people who are interested in discussing CRDs, how we use them, the future of them, to try and figure out where those fit in with the application CRDs that I've been talking about with the app dev working group, how this plays into Helm, and kind of how do we bring this together. There's really complicated ways we could go, simpler ways, and what we learned there was we aren't in agreement, and sitting down at a table for a half an hour or even having side discussions afterwards wasn't enough time to come to conclusions. And of course, we're going to communicate a path forward to, yes, there was Lostromos too. Thank you, Brian. It was another one of the examples there, and stuff similar to that that's using CRDs. We've got a lot to talk about to work out all the bugs and edge cases and kinks to cover, well, what Helm needs to do for people. And then there was we're going to kind of communicate the Helm 3 path forward, just to kind of say, hey, folks, we want to make sure everything's communicated well, so people don't say we don't know what's happening. We want to make sure that, you know, Helm 3 is kicked off. Where do we go from here? What are those steps? We want to make sure everything is communicated for everybody, and so that's one of the other action items that's going to be happening. And so I kind of just gave an overview real quick. We've got a number of other people on the line who were there. Does anybody else want to jump in and give their 2 cents?
I'll just jump in and say thanks everyone for coming. Who did. We learned a lot, and it was just a really nice event to get to meet people who are using Helm. So thanks for coming.
Is anyone going to email out an overview of the summit
Yeah.
with links to the notes and the YouTube channel and all that?
Yeah, Taylor Thomas took point on that, and so he's going to be getting some notes together with Matt Butcher in the next few days. So you should see something this week with all the calls to action, notes, videos, and all that.
Okay, thanks.
Yeah, we're also planning on sending out a survey, if it hasn't gone out yet, for the people who were there to give their feedback, because we want to know what folks thought. Anyone else who was there want to jump in and give any thoughts on the Helm Summit, discuss it in any way, shape, or form?
Well, I did want to say thank you to Michelle and all the other people who helped set the Helm Summit up. It was super useful, and like give a little applause just to say thanks. And I hope we continue to do this on a year to year.
Yeah, we do too. We're looking forward to finding the next location to have one of these. Anybody else? It's the last chance. Or once, twice, 3 times. All right, fantastic. Then the next discussion topic we have is on moving kube control apply to the control plane. Do we have somebody on to talk about that?
Yeah, can you hear me?
Sure can. The floor is yours.
Hi, everyone. I made some slides, which I will try and present here. Let's see if that works. Can you see that?
Yes, I can.
Let's see. Can I make it even bigger? All right. Oh, now I can't see you. I sent around this design doc, was that last week or the week before? and I've gotten some feedback on it, so I thought it was time to go shopping this around the various SIGs. Yeah, so I made some slides. I think everybody on this call is probably familiar with the existing kubectl apply. If that's not a good assumption, then please stop me.
You might want to bring some folks up to speed. I don't know that a lot of people know how apply works, and some folks may not even realize that the code for that lives in kubectl rather than in the API server.
All right, I'll just start from the top then, and if this is boring, you can chat or something, and we'll take it from there. You're all the first people to see these slides, so they might be a little rough. All right, so kubectl apply is a thingy that you give it partially specified objects, and magic happens, and those show up in your control plane, and then controllers actuate those objects, and they show up in your cluster. So there's really sort of two things that kubectl apply is. One is the operation that you perform on a single object to make that object look the way you specified in your manifest, and the other is the operation that you perform on an entire directory full of objects. So you can dump that whole thing into kubectl apply, and it'll make them all. I'm mentioning this right at the beginning just to warn you that I'm only talking about the single object apply case. So just a warning. Okay, let's talk in more detail about what kubectl apply is. So right now you have an object that's partially specified. It doesn't have to be fully specified because many fields are defaulted, or maybe the object on disk is a different version than the cluster knows about. So you may not even have all of the fields. But the essential fields are filled out on this object on disk. You run it through kubectl apply. If the object doesn't exist in your cluster right now, it will be created. If the object does exist, then some magic happens and the system updates some fields, and you get something that hopefully matches your intent. There's some bugs with that, which we'll get in a minute. But first, I want to, why is this a good thing? Who does this help? How is this better than the alternative is maybe a better way of asking it. And the alternative to having this system where you specify fields and then the system makes it look like that, the alternative ends up looking like either maybe a bunch of separate API calls. Like suppose you want to change the number of replicas. Well, maybe you have to, and you're writing a system to keep this up to date. You have to integrate with a particular API that's specifically for changing the number of replicas. Or you want to add an environment variable to your container in a pod template. You have to write an API specifically for doing that. So the idea here is phrasing this as a manifest file, a declarative manifest file, means instead of writing a API integration for every resource for every operation on that resource, which is a lot of API calls, you implement one API call, and that is the apply operation. And the system has the smarts, and we make the data model unambiguous enough so that it can deduce your intention when you give it your new desired state. Is that making sense? So another aspect of this, doing my bullets out of order, another aspect of this is that users interact with the exact API content that they're submitting to the system. And this is good for a number of reasons. One is users get familiar with the API resource layout. And if tools along the path from user to actuated system object, if they are all working on the common resource, then the tools themselves can be composable. If a tool is putting out bad output, the user can examine that output, and they're familiar with the format of that output, so the user can understand what the tool is trying to do. The user is learning the actual API resource in the system and not a not some other language that like constructs that resource for them. So your knowledge is more transferable if you switch to another tool. So that's sort of like, why is this a good thing? Why do we want to support it? And I think this is really the thing about the Kubernetes API that is actually an advance over other API systems. Like, why do we have the Kubernetes API system? This is why. You don't do this with gRPC. So after all that, why is it good? I have to tell you why it's not good. And you should not do anything imperative with this. It doesn't make sense. Don't charge credit cards. Don't open the pod bay doors. That's not what this is for. Most things in the Kubernetes ecosystem are declarative APIs. We have a couple imperative ones, but mostly it's declarative. And I want to caution API builders. It's easy to write an API that looks declarative but has stuff like field, charge credit card, Boolean, true, which is kind of cheating, and it's not going to work out very well. Okay, so now that we know why it's good and why it's not good, why is it hard? And the reason why it's hard is because the input to this operation is the user's previous applied state and their current desired state. And from these two pieces of information, we have to deduce what the user was trying to accomplish. So I think in general, that's like you need the full operational toolkit of human intelligence to figure that out. So we're going to cheat and reduce the scope of the API surface area until it's unambiguously defined. That's the idea. Okay. So that was just the introduction. So the goal of the kubectl apply, well, currently it's kubectl apply, but I'm changing it to just be apply. The goal of apply is to allow users and systems to cooperatively determine the desired state of an object. If you look at my, expand my speaker notes here. If you look at my document, I have more stuff about this. So we want a bunch of stuff. And I say the goal here is that the control plane delivers a comprehensive solution. This is because right now, all of this is written in the client side. So kubectl actually has logic which stores an annotation in objects. And when you run kubectl apply, it reads your object off of disk, it reads the annotation, it does a diffing operation, it constructs a strategic merge patch, and it sends that to the API server. Yeah, so that's what it does today. Our goal is to form the correct version of this operation, and it has to be located in the control plane. Okay. Non-goals, as I said, I'm not going to worry about the multi-object apply case for the moment. I think we have to solve the single object apply case before we can think about fixing the multi-object apply. I'm not, I think it's a reasonable extension, but I'm not discussing today adding an API that does arbitrary merges. So like I send two objects to the server, it sends me back the result without actuating anything. I'm not talking about that API. I think it's useful, but that's sort of kind of a trivial addition after we do the big chunks, and I don't want to design it here. There's additionally some sources of user confusion that cannot be fixed by moving things into the control plane, and so I'm going to exclude those for the moment. And that is, some users change the name of their object on disk and then rerun kubectl apply, and to their surprise, they get a second object rather than having the first object be renamed. This is just sort of fundamental to the way the system works. We use the name and the namespace to identify the object that you want to change. Yeah, so I don't have a good idea for fixing that, and I'm not going to attempt it here. Additionally, there's user model, like if you're trying to change the type of your service, maybe that works well, maybe it doesn't. That I think we can fix with additional validation. But again, I think that's sort of a separate topic from how you're attempting to make the change. Okay, so I want to talk about the actual proposal now that you have all that background information. So what is the problem? And here's some problems with our current system. User does a post, then they change something and applies. Surprise, when you did a post, it didn't store the last applied state annotation, and something strange might happen. Another one, suppose you start with apply, you or somebody else does a kube control edit, and then later you apply again with your original manifest. Surprise, that kube control edit, and maybe you wanted that to remain in effect, maybe you didn't. You're going to get something that you probably didn't expect. Another common one is I make a change locally, I apply again, and suddenly I own a bunch of defaulted fields that I didn't intend to. Alternatively, maybe I tweak some annotations. Maybe I'd make some changes to the last applied state annotation and apply that. Something strange will happen. If I make a resource and apply that, and then my coworker makes a few other changes and applies that also, then something very strange will happen because the file they're applying is not related to the file I applied, and the diffing operation will return nonsense. So why is it hard? We've had kube control apply since very near the beginning of the project, and it still has these bugs. But we've had a bunch of really smart people working on it. So what has sort of gone wrong? And the conclusion, I came up with two sort of reasons for why it's still broken. I think the practical reason is there's too many components have to change at the same time in order to get a fix. So if you want to fix a bug in the diffing or merging or any of that logic, right now today you have to change a schema. You have to change the strategic merge patch format, which is not versioned and very difficult to change. You have to change the client-side diffing logic. You may need a server-side patch as well. So it's like 4 different places you have to change to get anything fixed. Because we don't want to break old clients, you're looking at like a 2-release deprecation period during which you have to support the old broken behavior and the new non-broken behavior. So this is, practically speaking, incredibly challenging. And the other reason is, this is the reason that I hope to actually fix just by delivering a design doc, which is I think developers didn't have a clear mental model for how this feature was supposed to work. And so some fixes fixed it in this direction and some fixes fixed it in that direction. So I hope if everybody can read one document and understand how the feature is supposed to work, we can get our fixes aligned in the same direction. Okay, so actual components of the proposal. We're moving the logic into the control plane. I'm going to make a logical apply verb. I'm writing a dry run. This is so client can see, like, if I applied this, what are you going to do? I want to track a last applied state per client ID. This means if Alice applies one thing, Bob applies another thing, they don't work off the same last applied state. It also allows us to generalize apply to controllers. Because right now controllers send patches, or sometimes they update the entire object. I think the apply, if we get the bugs fixed, apply is just a more general and more functional variation of patch, with a more understandable format. Yeah, last apply annotation. No, should not be an annotation. I'm going to make it a field in metadata. So it's top level. Other API verbs can understand it. We can use the stored last applied states to help with error messages. I think I cover that in a minute. We can use this extra field to detect when a user is sending a object that they sourced from get, because it will include this. You should never have this field when you're sending a apply request. Yeah, and to support this everywhere, we need to add some extensions to Open API schemas. So like, I think this needs to work on CRD resources as well as built-in resources. we're running low on time, so I will go a little faster. Yeah, so new API verb. My current recommendation for the implementation is we're just going to send it as a patch. You'll send a particular content type. If you get a conflict, you get a nice error message. Horizontal pod autoscaler is managing spec.replicas. Are you sure you want to change it from 2,648 down to 5? Probably you don't. But it's easy to do that with apply today. Support dry run. Multiple appliers. Apply is more general than patch. Let's use it in controllers instead of patch. I would like to deprecate strategic merge patch. New home for the last applied annotation. And we will need to make some schema changes. If all goes better than could possibly be hoped for, I would like to have some sort of alpha in 1.11, which is why we're circulating the design now. And if we have an alpha in 1.11, then maybe we can have some kube control integration in 1.12. So that was the design doc that I circulated. Are there any questions there? There's another whole half of this, which is about the actual problem of doing a strategic merge diff, a structured merge and diff. So I think we're running low on time, so maybe I won't do this.
How about this? We could discuss this first part briefly here for the next few minutes. And did you want to come back, say maybe next week, and do chapter 2 to talk about how you're going to do the diff? Or how
why don't I circulate the document, and then you all can say whether you need to see that presented, because I haven't actually circulated that document yet.
Okay. Yeah, if you could do that to the SIG Apps mailing list, we'll go take a look at it this week.
Yeah. Okay, I will do. So I will put this slide up and maybe take questions.
Yeah. So you know, I don't know if a lot of people know this, but strategic merge patch, which has trouble, and I understand the issues with CRDs, that's actually something used in Helm today. And being able to call an API to deal with this, because we're doing it with standard objects today, when we do it, instead of importing libraries from kube control and doing that and passing it, that would make managing things a lot easier for us, I think, on the Helm side.
Yeah, I think I neglected to mention one of the most important. It's even bolded on the slide, and I didn't say anything about it. We need apply to be callable by any client in any language, and right now that's not the case.
Yeah, you can get it and go, and I'll be honest, trying to import it from kube control and then use that. If anybody tried to use Helm 2.8.0 and ran into bugs with CRDs, it was actually changes in the API that we didn't know, and just dealing with this space, because it's difficult with the changes and moving parts. And as you refer to it as being broken sometimes, has caused us some heartache and some pains. So making this easier, I think would make a lot of people happy.
To extend on what Matt said, a lot of the reason people have been vendoring code from kubectl is to get some of the semantics that are implemented in kubectl that you can't just like use client Go to get. To my knowledge, this is like the last one. Like the Reapers are dead. A lot of the other things that were kind of embedded as imperative logic in kubectl have been mitigated completely. But apply is still a big one. And thankfully, I mean, because Helm vendors it, Helm does it right. There are a lot of other interfaces to the system out there that try to achieve the same semantics as apply, and it's completely not consistent. So I feel like it'd be great to get this server side so that we can have a uniform experience across all of our tools.
Yeah. Sounds great. So I was, my purpose in presenting this was twofold. One, just informational, so you all know what I'm thinking, and two, to collect any blockers or things you think I need to cover in the design. My hope is to take this to SIG architecture as soon as they have a free slot and get like a design approval or something of that nature. So please let me know if there's anything you think the design needs to address.
So have you started a KEP for this yet?
No, I have a rather lengthy, it's in fact 30 pages design doc.
Okay.
With a bunch of tables, so I don't know how well that's going to translate to Markdown. Yeah, but I assume I will probably be Markdownifying this.
You can do tables in Markdown now, or at least GitHub flavored Markdown. So there is an option there. But yeah, no, I understand. I was just asking because I know that's where SIG architecture is going. Okay.
Yeah.
Great. All right. Well, it looks like our time is coming to an end, and I know people have other meetings. If you could circulate the document and this presentation out to the SIG Apps mailing list, we'll definitely take a look at this. I'm really curious, especially since we're in Helm 3 planning, how we can approach this. So thank you.
Yeah, I would love to see Helm send work in this as a series of tools that operate on YAML files in the Kubernetes API format. I think that'd be awesome.
All right. Well, with that, I think we can about call it and give everyone a chance to have a couple of seconds before they get to their next meeting. Thank you, everyone. Oh, and we normally do stand-ups in this meeting because we went long with demos and discussions, which is perfectly fine. We bumped those to next week. It was one of those things we thought might happen. So that's just been bumped to next week. So with that, everyone, have a wonderful week, and we'll see you out on the internet. Bye.